Good morning, everyone. This is Mrs. Bokerman. In these next couple videos, we're actually going to get into some really cool graphing that Polar is very useful for. Okay, so we're going to start with kind of something that we know in rectangular world. But again, remember, we're not going to ask you to graph anything on rectangular grid. It's always going to be on the polar grid. But in chapter 6, we actually asked you to graph functions that were similar to this, y equals 2 plus 2 sine theta, except in that chapter, we kind of put the 2 on the end because the 2 in front changes the amplitude and the 2 on the end moves it up or down. And so I gave you the rectangular graph over here. So how does this rectangular graph correlate to something on the polar grid? So notice this is what we're going to graph. We're going to graph r equals 2 plus 2 sine theta, but now on the polar graph. So just like rectangular, if you don't know how to graph something, we always said, hey, plug in x's and figure out your y's. Well, similarly, we can make a table of values, but instead of plugging in r's, you're actually going to plug in theta, because that's easier to find out. And the thetas that you should use are pretty much the axes, although you could pick any ones you want, but you're going to get a good picture of what's going to happen by just using these 5 points. So if I were to plug in 0, sine of 0 is 0, so times 2 is 0, so plus 2 would be 2. And I could keep going, so I could plug in pi halves. Sine of pi halves is 1, so 2 plus 2 is 4. And similarly, if I kept going and plugging in all these values, I should generate a 2, a 4, a 2, and a 0, and then back to 2. So in the 0 direction, I should go out to a radius of 2. In the pi halves direction, I should go up 4. In the pi direction, I should go over 2. And in the 3 pi halves direction, I should go to 0 and it back at the 2 pi. So it kind of follows here, then up here, then here, then here. And if you'll notice, this looks similar to a heart, which is why these are called cardioids. So every cardioid looks like this, except for it has different distances and it's facing different ways. But every cardioid will have the same number here and here. Now, there might be a minus sign in between, but we'll talk about that in a second. Okay, so my goal by the end of the video is for you not to be able to make a table, although when in doubt, you can, but I want you to be able to graph these rather fast without having to make a table of what they look like. They all have this heart shape. Okay, so let's do one more. What if I asked you to graph 3 plus 3 cosine theta? Okay, so again, you can make those points 0, pi halves, pi, 3 pi halves, and 2, and you could go through the process again of plugging those in. And if you were to do that, you would come up with 6, 3, 0, 3, and 6, which would look like this. Okay, now I am not surprised, I hope you are not surprised, that this is actually facing this way along the polar axis because it's a cosine graph. Okay, whereas the last one was a sine graph and it was facing up. That is not a coincidence. We talked about that with lines. We talked about that with circles. It's the same thing. Okay, now something more obvious that I want you to understand is let's count. 1, 2, 3, 4. I wonder what's going on. And 1, 2, 3, 4, 5, 6. I wonder what's going on. Okay, that is not a coincidence. It'll happen every single time. Okay, and more importantly, this is a length of 6, and then the other side is 0. This is a length of 4, and then the other side is 0. Okay, interesting. So how could I graph this rather quickly without having to make a table? Hopefully use that knowledge of what we just talked about. Okay, so it is a cosine graph. So I know it'll be facing along the cosine polar axis. Okay, now this is the first time where it's a negative. So instead of going the long way being this way or the long way being up along pi halves, the long way should be this way. And so I'm going to take those two numbers and I'm going to add them. 1 and 1 is going to make 2. So this is going to be a distance of 2, but it's going to be facing towards pi because it's a negative. And then the other side is going to be 0. Okay, so the long way is add those two numbers. The short side would be always 0. It's always going to hit the pole. Then the other obvious thing I want to point out is 1, 2, 3. And this one was a distance of 1, 2. Okay, that's because on these sides, the sign is 0. Therefore, this goes away. Similarly, This side, the cosine is 0 at pi halves and 3 pi halves. So this side goes away, and so you just have this number. So the other sides are going to be this number. So I'm going to go 1 this way and 1 this way, and then I'm going to make my little heart. Okay. And that's how you can graph them really quickly without making a table. So let's summarize what we just said. It does not matter if it's plus or a minus, and it does not matter if it's a sine or a cosine. If those two numbers are the same, it is a cardioid. In the next video, I'm going to talk about if those two numbers are different, which is actually a limacon. Okay. But for cardioids, you have to have a 2 and a 2, a 1 and a 1, a 5 and a 5. Doesn't matter. So the length of the heart is, I'm talking about the long distance, is you're just going to take those two numbers and add them together. And then the length to the side is just going to be A, because the cosine or the sine has been 0, and so that's gone. So you can graph cardioids kind of quickly. And the other side's always going to hit the pole. So there are cardioids. Let me know if you have any questions.